Hey, what's up, nerds? Today we're going to calculate the composition of a buffer with a given pH. So since this is a buffer problem, we're going to need to remember the Henderson-Hasselbalch equation. And so the Henderson-Hasselbalch equation is pH is equal to pKa plus the log of base over acid. Okay, and we're given a Ka instead of a pKa. So let's go ahead and calculate that pKa. So if we take the negative log of that Ka, then we end up with a value of 1.96 as the pKa for this problem. So this chemistry student is given a weak acid, HClO2, and they're wanting to add the conjugate base to it in the form of sodium chlorate or hypochlorite, whatever that is. Okay, so this is going to be our acid form, and this is going to be the base form. And we're given a pH of 2.48, so we can set the problem up by using the Henderson-Hasselbalch equation, and we can write in 2.48 is equal to 1.96 plus the log of our base form over our acid form. And the base form, we're going to use X as our concentration. And the acid form is going to have a concentration of 1.2. Okay, so our task then is to solve for X. So if we rearrange that just a little bit, we can get 0.52 on one side is equal to the log of X divided by 1.2. And to get rid of that log term then, we raise both sides to the 10 power. Okay, and when we do that, then raising it to making it the exponent of 10 cancels the log, and we end up with this. We get 3.31 is equal to X divided by 1.2. So that gives us an X value of 3.97, which the way we defined X has to be our concentration of the base. Okay, so the problem asks for how much of the base, what mass of the base should we add in order to get a buffer with a pH of 2.48. So we have to do a little bit of stoichiometry. What could be more fun than that, eh? So we're going to have our concentration. We'll start with our concentration, 3.97 moles per liter. And we'll multiply that then by our volume, 0.25 liters. And we'll multiply that then by, come on, make a good decimal point. There we go. And we'll multiply that then by our molecular or molar mass. So 90.5 grams per mole. And I just did that 90.5 grams in my head, so you might want to do that more accurately. And then we can cancel whatever cancels, so the liters cancel, the moles cancel, and we're left with grams. And to two significant digits, we should get 84 grams, which would be the answer that Alex is looking for. So there you have it, folks. That's it. Bye-bye.